next up, Meshack has come back. So we're hoping to get him up and running again, and we'll get it going this time. That is a company called Irradiance, and there is Meshack, and I see your screen. Here we go.
Okay, yeah, my apologies, judges and everyone, for what happened. My computer just went on blue screen, but I fixed it. So my name is Meshack, and I'm the founder of Irradiance Energy company. We are looking at supplying ubiquitous and limitless energy on Earth using the space-based solar power system of systems, and I'll explain that in a moment. So we're looking at the market size by population, as well as in the future. In 2050, we're expecting to be over 10 billion thereabout, and the electricity demand will be so high, reaching over 53,000 terawatts of hours. And solar energy is expected to be the main source, but as we know, less than 10% or 20% of it, of the sun's irradiance doesn't get to the Earth's surface. I mean, 80% is reflected by the surface, the atmosphere, some portion is absorbed, and only less than 20% gets to the Earth's surface. So we have had this conversation about the space-based solar power and how it provides solutions based on some limitations about the terrestrial energy. And we're looking at deploying space-based solar power system of systems to overcome the atmospheric barrier, and then providing clean and sustainable energy, because it's always sunny in space. And our mission is to look at a serviceable, obtainable market of the global projections of solar PV market, about $185.62 billion projected by 2027. This is the concept that we are looking at. We will deploy about 10 systems in low Earth orbit, sun synchronous. And on the left, you see a bit of a movie of how we have simulated this in a rough way, deploying and installing ground stations in different places on the Earth, and using microwave beam to downlink. And we would do also storage of the excess power, and our ground stations will be co-located not quite far from our clients, who are the national grids and other power aggregators. So we have modeled the business case, and we are looking at lowering the cost of electricity below the levelized cost of electricity globally, which is about $0.01 per kilowatt of hour. And our mission is to satisfy the customer and to have more clients. And our direct clients will be the national grids. So this is the part of the cost revenue analysis that we have done for the 10 system of systems, and each one targeting about 1 gigawatt of hour per, to the ground. And if we do that cost analysis, we're going to break even at around year 4, year 5. And the rest, the cost will be going down. So what we are looking for at this point is the prototyping. We're looking at delivering a minimum viable product. As you can see in this illustration, we are looking at a system of 2 space cubes. We're not calling them CubeSats because CubeSats have power limitations, but we are looking at space cubes, a modification of CubeSat probably, and 100-meter long of a new material called Perovskite in tandems, and harvesting about some few kilowatts of hours of energy back to Earth. Perovskite, I'm going to talk about Perovskite in a moment, but we're looking also at avoiding the launching cost by piggybacking on free rides like the NASA CubeSat initiative and KiboCube or Bartolomeo, depending on the size and the requirements. So Perovskite is an inorganic material that has been proved to exceed in terms of efficiency other technologies like the silicon wafers that are currently being used on satellites. Perovskite is also lighter and cheaper than silicon, and it can be used flexibly in space, but it has not been tested yet. Perovskite solar cells can be manufactured using simple additive deposition, and this makes it easier for concepts and technologies like additive manufacturing in space. And because of the compositional flexibility of the perovskite, they can also be tuned to ideally match the sun spectrum. What happens is in a tandem, you have different layers of this perovskite, and each can be used or be modeled to harvest a different spectrum of the sun's energy. The material is facing a lot of challenges, not a lot, but a few challenges. The main one is being stabilization and degradation of the material. It degrades quickly. It has been tested severally on Earth. And also the stability of the material has not been to that level of satisfaction. But we want to take it to higher level and do some more research about how to stabilize the material and how to make it more useful in space. And so the immediate needs that we have is to test the perovskites on the ground and do deposition and crystallization, as well as radiation and thermal hardening, and deployment and testing of the perovskite tandems through the concept that I showed in the MVP. So we're looking at production and incubation facilities, as well as seed funding for the prototype. And the seed that we are looking at, we are asking for is about 650,000, excluding the launch cost and as a lean budget, without also including a lot of salaries and other expenditures. So in terms of traction, we have had quite a number of advancement. We recently entered an NDA with Nano Avionics to fly and test the perovskite in space. We have also engaged at an early stage with investors, an example of Abu Dhabi Investment Office, who actually made a commitment that as soon as we get matching funds and we prove the technology, they are really interested to invest in the program. We have also done a bit of customer discovery. We are engaged with the National Grid of the US, and they gave us some of the issues that they usually face when they procure power from renewables on Earth. The major one is that, the grids, they are not able to sustain or to stabilize the grid. But our system is promising to stabilize the grid, and they will be happy to be our clients if we succeed in the technology demonstration. So we have also contested in the ESA Open Space Innovative Platform. Although we didn't win, but we went far in terms of coaching, as well as getting ideas and teaming up with other teams to do the project. We're also starting a new research hub at a university in Angola. So the team that is leading this is myself and Jarin. We have Erdrich and Marco. Most of us are engineers, but we have Jarin, who has done marketing and strategy. We also have on our board John Mankins and Andrew Andrin, and they have done a lot of work in this industry, especially Dr. John Mankins. We credit him for that. We are also onboarding legal expert, power grid engineer, as well as integrated circuit engineer and a cloud service engineer. And yeah, that's it from me. Thank you.
And right on time. Beautiful. Thanks so much. Everyone's been right on time today. It's just a testament to all the hard work everyone has done. It's been really amazing so far. I know that's going to continue. Judges, what do you have to say?
So I've been trying to get space-based solar power economics to close for a long time, and it is incredibly difficult to compete on a price point basis, given the distribution networks that have to exist and the existing efficiencies within the power production and distribution systems on the Earth. The two exceptions are when there is no distribution or production capability to compete with. For example, the US military continues to look at this for forward observing bases where there is no industrial capacity. They're basically in the middle of absolute nowhere. The other is when for whatever reason, I think as somebody, Chris Medley says in the chat, when a national government decides to quantify all possible and impossible and even improbable externalities into the cost of its electricity production and causes its internal pricing for Earth-based production to be incredibly artificially high, which so far no government has been willing to do. What's sort of the plan for breaking into this and being able to compete against terrestrial energy production and distribution? Because the entire cost of electricity is not just the production, it's the supply chain that leads up to it, and then the supply chain for distributing, storing, and using and metering that power.
Yeah. So the first question is that, yes, there's some level of uncertainties with the government regulation. But as we have seen with the pronouncement of countries like China, Japan, that they will be deploying space-based solar power systems, it ushers in the fact that it's a concept that is going to be realized sooner than later. And so our work, we are projecting that between now and 2024, for instance, there will be a lot of, or a level of advancement in the technology itself. We are also piggybacking on other dependent technologies like in-space manufacturing, and that's why we chose the Perovskite, because it can be deposited in space or imprinted in space. More than the silicon wafers can be done. And regarding the competition with the terrestrial-based systems, our approach is actually not to go directly to the consumers themselves, but to work with the grid aggregators, so to say, or the national grids, and to sell them the power at a lower cost than they usually buy from the current renewables. And by that, competing with their pricing and stabilizing their grids. I don't know if I captured all the points.
Yeah, that's fine. Yeah, I think there's still a lot of challenges here. It's nice to see companies trying to crack this nut, but it's still a very hard one unless you get a national government involved in subsidizing a lot of the work. Definitely would like to stay in touch, though.
Okay.
I was just curious. You have a pretty full team listed. How many are full time? How many are part time?
So for now, we don't have a full time because we're in the transition. We have been working for about, I would say 8 months, because the first 2 months were about settlement. And then the COVID situation came and we have been working offline most of the time. But in the near term, we will be, and we're talking about early next year, we'll be full-time transitioning. The company has been registered in the US, and we are all looking at being full-time to the company and adding, as I said, that we are looking at onboarding other team members who are critical, like engineers as well as legal experts, to maneuver through the legal frameworks.
Gotcha. And you mentioned 650K for an MVP, but it sounded like that was primarily materials and lab, not including salaries. How much would you need to raise, to bring on, at least a couple folks on the key team full time?
So what we did is we phased the project into different parts because in the first phase it's full time. In the first phase it's not full time. People working probably on irregular basis, but as we transition to the full time, we are looking at going to the next level of raising fund. The first one is the MVP, of course, with a couple of engineers, probably no need for the legal expert at that time, probably no need for the power grid engineers at that time. A couple of us, as we can be able to deliver that MVP. But as we transition to the next level, which is actually deploying like I would say the second series of the project, we would need full-time members. And that's when we, in our budget proposal for the next phase, we have phased it into different, about 5 stages. And then the next phase, it will be about a request of about 1.5 million USD.
Great, that's helpful, thanks.
Okay, hearing no other questions from the judges, then I guess.
I have one
Okay,
quick.
never mind.
Where are you guys based out of?
So the company has been registered in Delaware, but we are based in our different locations. Myself, I'm in Ethiopia, and we have Edrich, who is based in Finland, and we have Jarin, who is based in the US, and Marco in Angola.
Okay, great, thank you.
I have one more question, actually. And by the way, Ethiopia looks remarkably like the Bay Area on your camera. The question I have is, for the MVP, who is your first, like your target customer? Because there's lots of different use cases. If you can actually make the cost of energy work and you can get all this stuff to work, but who's your starting customer? Like, who would you say they would buy it if I can make it work tomorrow?
So for the MVP, we are not looking at actually selling, but proving the technology. We're looking at having a partner microgrid that we can at least harvest some kilowatts of hour and be able to prove that we can integrate that within the grid, the microgrid. That will be a proof of concept to, go to major grids that will buy the power from us.
Great, thanks.
Okay, thanks so much. We need to move ahead. So Meshack, if you can give up the screen. Thank you so much.
Thank you.
And
Thank you, appreciate it.
yep, absolutely.